Do you ever feel like the clock is just physically ticking faster when you're walking down a busy city street?
Oh, yeah, absolutely.
Right. Compared to, say, sitting on a quiet porch in the country. It's like the actual mechanics of time have been, dialed up somehow.
Like someone hit fast forward.
Exactly. You're on a crowded sidewalk, you're weaving through pedestrians, the ambient noise is just blaring, and suddenly you look down at your watch and wonder where the last 3 hours went.
They just vanish.
But then maybe you take a weekend trip to a cabin, or I don't know, you just sit by a lake for an afternoon and time seems to stretch out.
It really does. The sun takes forever to set.
Yeah, the day feels expansive, almost elastic, It's this universally relatable feeling, the sensation that time is slipping away, that days and years are just flying by faster than ever before when we're immersed in our modern routines.
It is an incredibly common phenomenon. And what's so compelling about it is that most people just write it off as a simple trick of the mind.
Or they just blame it on getting older.
Right, exactly. We operate under this culturally ingrained assumption that time is a strict, unyielding constant. A second is a second, an hour is an hour.
Because that's how physics works.
Right, but human perception doesn't adhere to physics in that way. Our internal subjective experience of that hour is incredibly volatile.
Which brings us to the core of what we're going to explore today. So, welcome to Today in the Hypothesis. Today, we are doing a deep dive into a really dense, multidisciplinary research paper.
It's a heavy one.
It is. It's titled Deconstructing Temporal Acceleration, and it's authored by an independent researcher named Victor H. Sertich.
Yeah.
And the mission of this deep dive is to investigate a very specific hypothesis presented in this paper. The initial question is basically this: does time move faster in cities because our brains are understimulated and simply, spacing out?
Right.
While rural environments provide, endless novel stimuli for our brains to map, the underlying idea being that cities are so structurally repetitive, grid streets, endless concrete, glass facades, that our brains just sort of go on autopilot and gloss over the day.
So I want to drop a major spoiler for you, the listener, right at the top here.
Oh, go for it.
The foundational premise of this hypothesis that time subjectively feels faster in the city is an absolute empirical fact.
Wow, okay.
Yeah, it has been measured, documented, verified across cognitive science, linguistics, sociology, all of it.
But then there's a big but here.
A huge but. However, the scientific explanation proposed in that initial hypothesis, the idea that we are understimulated and just spacing out, is entirely backward.
Rightly wrong.
Completely. What the research actually reveals is that our built environments are actively hijacking our internal clocks. They're hijacking our memory encoding systems and our fundamental cellular biology in ways that are far more intense than mere boredom.
Okay, I have to say, I want to challenge that original spacing out hypothesis right out of the gate anyway, because when I first read it, my immediate reaction was just total disbelief.
It doesn't make sense, right?
No. The idea that a modern city causes cognitive understimulation, that flies in the face of literally anyone's lived experience.
Oh, absolutely.
Anyone who has tried to cross a complex intersection in a major metropolis knows this. Like you're dodging aggressive taxis, you're trying to filter out flashing digital billboards, keeping an ear out for delivery bikes and sirens. I mean, it is the exact opposite of understimulating.
It's a sensory assault.
Right. It's like trying to drink from a sensory fire hose.
Right.
You are just being bombarded with data.
Your intuition aligns perfectly with cognitive neuroscience on this. To dismantle the spacing out myth, we really have to look at attention restoration theory, or RT for short.
RT.
Yeah. Yeah. This framework categorizes how the human brain processes environmental stimuli into two highly distinct modes. We have hard fascination and soft fascination.
Okay, so what's the difference?
Well, the intersection you just described, dodging the taxis and billboards, that is a textbook example of hard fascination.
Because it's forcing me to pay attention.
Exactly. Urban settings are dense with aggressive artificial stimuli. Advertisements use high-contrast colors that are literally designed to hijack your visual cortex. Vehicles move unpredictably.
Sirens, jackhammers.
Construction noises, yeah. They hit frequencies that trigger auditory startle responses. These things forcefully capture your attention from the bottom up.
From the bottom up, meaning my brain doesn't have a choice.
Right. Evolutionarily speaking, sudden movement and loud, jarring noises signal potential danger. So your brain have no choice but to process them.
I mean, I can't selectively ignore a bus hurtling toward me no matter how much I might want to space out, you know?
Exactly. You'd be dead.
But it's not just the external environment attacking my senses. I also have my own internal goals, right? Like
Yeah.
I'm trying to remember an address, or I'm listening to something, or I'm planning my grocery list. So while my brain is being assaulted by bottom-up stimuli, I am simultaneously trying to employ top-down, directed attention.
Precisely. And that's where the exhaustion comes in.
Yeah.
Your prefrontal cortex has to work in absolute overdrive to actively inhibit all those flashing, noisy distractions so you can focus on your goal.
Wow. So it's fighting a war on two fronts.
It is. That active inhibition is the key mechanism here. Your prefrontal cortex is constantly acting as a bouncer, basically denying entry to millions of irrelevant data points.
You can't come in, neon sign. You can't come in, honkin' horn.
Exactly. And that constant suppression drains your cognitive reserves at an astonishing rate. It just exhausts your working memory capacity. The brain in a city is never understimulated. It's operating at a state of hypervigilant tonic alertness.
Just constantly filtering, computing, discarding.
Non-stop.
So the fatigue we feel in a city isn't from boredom at all. It's from the sheer metabolic cost of playing neural defense all day. We are working incredibly hard just to maintain a baseline of functional attention.
Yes. Now, contrast that cognitive drain with soft fascination.
Which is the other mode of RT.
Right. This is the state induced by natural or rural settings. Nature is visually dominated by what mathematicians and physicists call natural fractals.
Fractals, like repeating patterns.
Exactly. Self-similar recursive patterns. So think of the branching networks of trees or the ripples on the surface of a pond, the complex but ordered shape of clouds, or, the way a fern leaf unfurls.
Oh, right, where the tiny leaf looks exactly like the whole leaf.
Yes. These patterns contain high mathematical complexity, but they are remarkably easy for the human visual system to parse.
Because our visual cortex evolved over millions of years specifically to decode those exact spatial frequencies, right?
Without a doubt. Natural fractals induce a bottom-up, involuntary attention that doesn't trigger a threat response.
So it grabs your attention, but gently.
Beautifully put. You look at a forest canopy swaying in the wind, and your brain pays attention effortlessly. You don't have to force yourself to analyze it, and crucially, you don't have to actively suppress it.
Because it's not a threat.
Right. Because it is aesthetically pleasing and statistically predictable, your prefrontal cortex, that top-down directed attention mechanism that was burning so much energy in the city, it finally gets to stand down.
It gets to take a break.
It rests and replenishes its neurocognitive reserve.
Oh, wow. So this is actually where true spacing out occurs, but it happens in the natural environment, not the urban one.
Exactly.
Because the prefrontal cortex isn't actively battling an onslaught of flashing lights and car horns, the brain can enter a state of true mind wandering. You can engage in spontaneous internal reflection. The environment holds your attention gently rather than demanding it aggressively.
And the clinical data backing this up is incredibly visual and honestly really robust. The paper dives into oculometrics.
Eye tracking studies.
Yeah, eye tracking. When researchers fit subjects with eye tracking equipment and ask them to navigate or even just view images of built urban environments, the resulting data reveals a highly erratic visual search pattern.
Erratic.
You see a massive count of visual fixations, but the duration of each fixation is incredibly short.
Meaning their eyes are darting frantically, like from a street sign to a pedestrian to a glowing window to a crosswalk, just back and forth.
Exactly. The visual system is desperately attempting to map an inherently chaotic, non-fractal environment. That takes massive cognitive effort.
I can imagine.
But when researchers expose those same subjects to natural scenes, the eye movement topography changes entirely. The total number of fixations drops significantly, and the duration of each individual fixation lengthens.
So they're staring at things longer.
Yes, the visual search becomes smooth, sweeping, and relaxed. The brain isn't struggling to map the rural space, it's processing the geometry fluently.
So if we were looking at a heat map of someone's vision in a city, it would just look like a scattered, frantic mess of tiny dots.
A total mess, yeah.
But in a forest, it would be a few large, deep pools of focus.
That's a great way to visualize it.
And the neurological synchronization goes even deeper than just eye movements, right? Let's look at the electroencephalography data. The EEG stands from the paper. Specifically, the metric of intersubject correlation, ISC.
ISC is such a fascinating metric. It essentially measures how similarly a group of different individuals' brains are processing the exact same visual input.
Okay, so if I show 10 different people a video clip,
Right. Are their brainwaves syncing up, or are they all exhibiting divergent neural activity?
and according to the paper, when people view green spaces or natural environments, they exhibit a 26% to 40% higher brainwave synchronization, a massively higher ISC compared to when they view urban boulevards or busy highways.
A 40% increase in neural synchronization across different subjects is a staggering statistical leap.
That's huge.
It is. It indicates that the brain is processing the visual input of nature without friction. Human brains know exactly what to do with a tree, a mountain, or a grassy field. It triggers a standardized, low-cost neural processing pathway.
You're built for it.
We are. But when looking at a city, everyone's brain does something different. One person's visual system darts to a threatening taxi, another gets distracted by neon signage, resulting in erratic, divergent, high-cost neural processing.
Man, this maps perfectly onto that specific, almost hollow type of exhaustion you feel after a day in a crowded city center.
You know the feeling.
Oh, intimately.
Hmm.
You might spend a Saturday walking 5 miles through downtown, running errands, taking the subway, weaving through crowds. Compare that to walking 5 miles on a hiking trail in the woods.
Both demand the same physical output from your legs.
Right. But the city exhaustion feels entirely different. It's a deep cognitive drain. You feel irritable, your focus is shot, you might even have a mild headache.
Yes, that is the physical sensation of your prefrontal attentional bandwidth being completely depleted. Your directed attention tank has run dry.
Just completely empty.
And that profound cognitive depletion is the necessary foundation for understanding why our perception of time accelerates.
Okay, let's get into this because this is where the paradox really hits.
Right. If your brain is constantly running on empty, just trying to navigate the present moment, it fundamentally alters how it records the history of the day.
Which brings us to a really compelling paradox. We've established that our brains are working incredibly hard in the city, processing massive amounts of data, actively suppressing noise, burning through cognitive reserves.
Yes.
If the brain is doing so much intense computational work, why does it feel like the time just vanished? Shouldn't a hyper-busy brain make time feel longer simply because so much happened?
It seems totally counterintuitive at first glance.
It really does.
To resolve the paradox, we have to recognize that the human brain does not process time as a single, unified construct. We have to separate how we experience time into prospective time and retrospective time.
Okay, I want to introduce a tech-based analogy here to illustrate this because I think it clarifies the mechanism perfectly.
Sure, go ahead.
Does our brain act like a video compression algorithm?
Oh, that's a good one.
Right. Imagine I set up my smartphone to record an hour of a completely static blank brick wall. The resulting video file size is going to be tiny. The algorithm recognizes that nothing is changing from frame to frame, so it compresses the data. It doesn't need to write new information.
Exactly.
But if I record an hour of a chaotic fireworks show, with explosions, sparks, colors changing every single millisecond, the file size is massive because the algorithm has to write complex new data for every single frame.
Right.
So are our memories compressing our urban routines because, despite all the immediate noise and chaos, they're ultimately highly repetitive, like the brick wall?
That analogy perfectly encapsulates what neuroscientists call the metabolic and episodic memory model of retrospective duration.
That's a mouthful.
It is, but your video analogy nails it. Let's delineate those two types of time perception to see how the compression works.
Yeah.
Perspective time is your judgment of duration in the present moment while you're actively engaged in a task or waiting for an event.
So, like, if I'm stuck in gridlock traffic,
Or waiting for water to boil. You are actively monitoring the passage of time. In those specific, highly attended moments, time actually feels agonizingly slow.
the classic watched pot never boils phenomenon.
Yes. But retrospective time, which is what dictates our overarching sense of a life passing by, is how you evaluate duration looking backward.
When you ask yourself, where did the last month go? Or how did this year fly by so fast?
Exactly. When you do that, your brain is not consulting some internal ticking biological metronome. Retrospective duration is calculated by surveying the density and distinctness of episodic memories that were encoded in your hippocampus during that specific time interval.
Wait, so our backward-looking judgment of time is entirely 100% reliant on the creation of new memories?
Yes. The paper even highlights a mathematical formula for subjective retrospective duration to formalize this.
Oh, let's hear the math.
It posits that subjective time, let's denote it as T sub S, is a function of the density of unique episodic memory encodings, which we'll call M sub E,
Okay, memory encodings.
divided by objective clock time, TSABO.
So subjective time equals unique memories divided by actual clock time.
Exactly.
So if I manage to pack a massive density of highly unique, vivid memories into a single week, that week will feel incredibly expansive in retrospect.
Think about the first week of a vacation in a highly novel environment, perhaps a foreign country you've never visited.
Everything is new.
The architecture is different, you're navigating a new language, the food tastes unfamiliar, even the ambient smells are new.
Hmm.
Your hippocampus is furiously writing new data for every waking moment.
Going back to the analogy, your brain is recording the fireworks show.
Yes. When you look back at that single week from the airplane ride home, it feels like an entire month has passed because your memory bank is densely packed with novel episodic encodings.
And this encoding process relies on a very specific mechanism within the hippocampus, doesn't it? The paper details the function of CA1 time cells.
The CA1 time cells are remarkable. They are populations of neurons in the hippocampus that literally fire in highly specific sequences to bridge temporal gaps between distinct events.
So they're like the timeline organizers.
Exactly. They organize your memories into a coherent chronological timeline. When a novel event occurs, a specific sequence of CA1 cells fires, effectively stamping that memory with a unique biological timecode.
But here is where the urban paradox really takes hold. If I am living in a bustling metropolis like Tokyo or New York, shouldn't my hippocampus be encoding a ton of distinct memories?
You'd think so.
I mean, the city is not a static brick wall. It's loud, it's vibrant, there are millions of people, constant movement. Why does an entire month in a vibrant city compress and fly by in a flash?
The urban paradox exists because of the friction between immediate perceptual noise and macro-level structural repetition.
Okay, unpack that for me.
Well, yes, there is high momentary perceptual noise, the sensory fire hose we talked about. But zoom out and look at the actual architecture of your daily schedule. In an urban environment, daily life is usually rigidly regimented and highly repetitive.
Oh, I see.
You wake up at the exact same time, you walk down the same street to the same subway station, you swipe your card at the same turnstile,
You sit at the same desk in the same office, buy a coffee from the same shop.
and you navigate the exact same crowded sidewalks to go home.
So the micro content of the frame might change slightly. Maybe I sit next to a different stranger on the train today, or a different car honks at me, but the macro structure of the frame is identical day in and day out.
Furthermore, it is compounded by what we discussed regarding attention restoration theory. The city is constantly draining your directed attention. You are living in a state of chronic cognitive depletion.
Right, the bouncer in my prefrontal cortex is exhausted.
And biologically, when the brain is fatigued, synaptic plasticity is severely dampened. Synaptic plasticity is the ability of neurons to strengthen or weaken their connections. It is the fundamental cellular mechanism required to encode new memories.
So not only am I essentially repeating the same structural routine every day, but my brain is so metabolically exhausted from playing defense against the sensory noise that it lacks the plasticity to properly hit the record button anyway.
The fatigue actively suppresses the robust activity of those CA1 time cells.
Wow.
So you live out your month in the city. Then at the end of the month, your brain queries the episodic record to gauge how much time has passed.
Now what does it find?
The record is incredibly sparse. It's a blur. The neural pathway for a Monday commute is completely indistinguishable from the Thursday commute 3 weeks later. There are almost no highly salient, distinct temporal markers to differentiate the days.
The video compression algorithm saw the identical structure of the routine, realized no deeply novel information was being presented, and just compressed a 30-day month into a tiny generalized package.
And because that memory package is so small, your brain makes a false duration inference. It calculates, well, I don't have many distinct episodic events stored for this interval, so not much time could have possibly passed. That month must have flown by.
It's a terrifying realization, honestly. We are systematically deleting our own perception of our lifespan because our environments are too exhausting to allow us to record it.
It's sobering.
But conversely, this explains why childhood felt so endlessly long. Think about a summer break when you were 8 years old.
It felt like a lifetime.
Every single day was an exploration, a novel stimulus, a new game, and we were operating in environments where we weren't chronically fatigued by the top-down directed attention demands of modern urban survival.
Childhood is the ultimate state of high episodic memory encoding paired with high synaptic plasticity. We haven't yet habituated to the world, so the brain records everything in vivid detail, expanding our perception of time. When we go to nature as adults, We simulate a fraction of that. The attentional bandwidth returns, allowing for rich internal processing, high emotional reflection, and clear memory consolidation.
You notice the subtle shift in the wind, the smell of damp earth.
Exactly.
Mm.
The memory record of a weekend in the woods becomes dense, expanding your retrospective judgment of those 2 days.
So we've clearly established how cognitive overload and memory compression warp our subjective sense of time. But this paper pushes the boundaries even further.
Much further.
We have to look at the physical infrastructure of the city itself. This brings us to a massive physiological component, chronobiology and artificial light at night, or ALAN.
Alan, yeah.
Because there is a biological acceleration happening whether you are paying attention or not. So let me pose a hypothetical to you.
Okay.
Even if I never leave my home zip code, even if I just sit in my apartment downtown all day with a relatively low cognitive load, just by virtue of living in a modern city, is my body reacting biologically as if I'm constantly jet lagged?
The research indicates exactly that. The built environment is overriding your internal biology.
That's crazy.
To grasp the severity of this, we must look at our evolutionary anchor. Human temporal perception and cellular function didn't develop in a vacuum. Over millions of years of hominid evolution, our internal biological clocks evolved in strict, unforgiving alignment with the natural 24-hour solar cycle, the geophysical rotation of the Earth.
The simple, absolute binary of light and dark, day and night.
Exactly. In natural settings, the transitions between light and dark are sharp, consistent, and unambiguous. Sunrise and sunset govern the physiological day. But urban environments introduce a massive, continuous environmental disruption. Alan.
Artificial light at night. It's so ubiquitous we don't even register it as a pollutant anymore.
But it is.
Street lights, commercial signage, 24-hour digital billboards, high-rise office towers left illuminated, car headlights, and just the general ambient light spillover that creates a permanent glowing dome over a metropolis. It is functionally impossible to escape.
I know you've experienced this living in an apartment where a streetlight shines directly into the bedroom.
Oh, yeah.
Or the glow of the city makes it so the room never gets truly pitch black. It feels like a permanent state of weird twilight.
Yeah, you have to buy blackout curtains just to sleep.
And that twilight is actively altering your neuroendocrine system. The mechanism is fascinating. Alan, especially from modern LED infrastructure, is heavily biased toward short-wavelength blue light.
Blue light, right. We hear a lot about that with screens.
Right. When this blue light enters your eye, even at ultra-low lux levels, even just a faint glow seeping through the edges of your blinds, it stimulates a very specific, highly specialized type of cell in your retina called intrinsically photosensitive retinal ganglion cells, or iPRGCs.
Intrinsically photosensitive retinal ganglion cells. What is their specific role in this biological clock?
They're essentially non-image forming light detectors. Their primary job isn't to help you see shapes or colors. Their job is to measure ambient light levels and communicate directly with the suprachiasmatic nucleus, the master clock in your brain.
Okay, so they're just light meters.
Exactly. When iPRGCs detect short-wavelength blue light, they send an immediate, powerful neural signal that suppresses the pineal gland's production of melatonin.
Melatonin being the primary neurohormone responsible for nocturnal biological timing, right? The signal that cascades through the body to initiate the sleep state.
Correct. In a natural environment, as the sun sets, blue light scatters and disappears from the atmosphere. Red and amber wavelengths dominate briefly, and then profound darkness falls.
Like a campfire dying down.
Right. In the absence of blue light, the iPRGCs stop firing, and the pineal gland floods the bloodstream with melatonin. But in the city, the relentless blue light from Alan tricks those iPRGCs into believing the sun is perpetually hovering just above the horizon.
So the body thinks it's always dusk,
The melatonin suppression signal never fully turns off.
which obviously wreaks havoc on our ability to fall asleep.
But the downstream effects are far more insidious than simple insomnia. Chronic melatonin suppression delays your entire circadian phase timing. It perturbs the rhythms of your core body temperature. Your body needs to drop in temperature to enter deep, restorative, slow-wave sleep. And the light signal prevents that necessary cooling. It fragments your sleep architecture.
Wow. So how does this fractured biology directly translate to the subjective feeling of time moving too fast? Because that's the core question here.
It all circles back to the suprachiasmatic nucleus, the SCN. Because your sleep is delayed and your melatonin profile is suppressed, your internal master clock becomes completely desynchronized from external objective time.
They're out of sync.
Right. The alarm clock on your nightstand says it is 7:00 a.m. The municipal schedule says it is time to wake up, commute, and be productive. But your biological clock, delayed by the ambient artificial light, is convinced it is still the middle of the biological night.
Oh, I see. You are forcing yourself into the demands of the day in direct opposition to your cellular state.
This biological misalignment creates a persistent baseline state of physiological stress. To force you awake and keep you functioning when your internal clock demands rest, your endocrine system pumps out elevated levels of cortisol, the primary stress hormone.
So you're just running on stress.
You are operating in a chronic, low-grade fight-or-flight state. This hormonal profile creates an acute biological sensation of temporal pressure. Your body literally feels like it is constantly playing catch-up, generating the anxious sensation that time is slipping away faster than your organism can process it, because biologically you are permanently lagging behind the external clock.
That is profound and honestly a little disturbing. Our cities are physically engineered down to the wavelength of the streetlights to keep us in a state of perpetual biological panic regarding time.
It's a systemic issue.
But the paper doesn't just stop at light. It bridges this evolutionary mismatch to visual processing as well, comparing urbanites to the Himba people of Namibia. Let's talk about that.
The comparison with the Himba people perfectly illustrates the neuroenergetic cost of our environment. The Himba live in remote, arid, relatively sparse natural landscapes.
Okay.
Researchers studying their visual processing found that they display a robust local processing bias.
Local processing bias. What does that mean in practice?
This means their visual and cognitive systems naturally, effortlessly attend to specific, fine details in their environment. They can spot a subtle change in the brush, a distant animal track, or a specific geological feature without suffering any cognitive fatigue. Their evolutionary hardware is tuned to extract high-value detail from a visually quiet landscape.
But if you take that exact same evolutionary hardware of the human brain and drop it onto a sidewalk in downtown Manhattan.
It faces immediate catastrophic failure if it tries to operate the same way. There is simply too much dense visual clutter. If an urbanite tried to utilize local processing, if they tried to consciously look at every single face, read every single advertisement, analyze every vehicle, their brain would instantly crash from sensory overload.
It's just too much data.
Way too much. So the urban brain adapts by forcing a global processing bias. It prioritizes the overall structure of the scene, the general flow of the crowd, the broad shape of the street, and violently filters out the specific details.
We blur out the edges of reality just to survive the walk to the coffee shop without having a panic attack.
Exactly. But that active filtration mechanism is incredibly metabolically expensive. It requires massive amounts of neuroenergetic reserves. At a cellular level, it rapidly drains adenosine triphosphate, or ATP, in the hippocampal and prefrontal neural pathways.
ATP being the energy currency of the cell.
Yes, ATP is the literal energy currency of your cells. Inhibitory interneurons, which are responsible for suppressing all that irrelevant visual data, are highly metabolically demanding.
So we are quite literally burning through our cellular battery, depleting our ATP, just trying not to look at things in the city.
And as that ATP depletes, you experience that profound mental exhaustion we discussed earlier, which loops right back to the memory model. Your brain lacks the energy to lay down time codes, your hippocampus fails to encode distinct episodes, and your body is pumped full of stress hormones because the streetlights tricked your SCN into thinking the sun never set.
Okay, we've established an incredibly robust internal model here. We've got exhausted prefrontal cortices, memory compression in the hippocampus, ATP depletion from forced global processing, and melatonin suppression from blue light.
It's a perfect storm.
It really is. But surely humanity didn't organize these cities this way by accident. The physical environment is a reflection of external socioeconomic forces that are enforcing this temporal acceleration. Who or what is continuously pushing the accelerator pedal?
To understand the external pressure, we really have to pull back and look at the macro history of how human societies have organized time. Because time, conceptualized as a strict, quantifiable, divisible grid, is a remarkably recent human invention. For the vast majority of human history, particularly throughout agrarian eras, life operated on what sociologists and historians define as task orientation.
Let me unpack task orientation because I find this historical shift fascinating. Under task orientation, the work itself dictates the time. In rural, pre-industrial history, time was inextricably tied to natural phenomena and the immediate physical requirements of survival.
Exactly.
You planted when the soil thawed, you harvested when the crop was ready, you milked the cow when it needed to be milked, and you stopped working when the sun went down. You couldn't bribe a crop to grow faster, and you couldn't delay the changing of the tides.
No amount of rushing would change it.
Right. Time was elastic, highly contextual, and embedded directly into the execution of the labor. If the task took 3 hours, it took 3 hours. If it was finished, the time was finished.
That is an excellent summary. In a task-oriented society, the human being is in dialogue with natural cycles. But the rise of industrial capitalism and mass urbanization fundamentally shattered that relationship.
The Industrial Revolution changed everything.
The factory system necessitated a shift from organic task orientation to abstract clock orientation. In urban industrial centers, human labor was divorced from natural cycles and time became explicitly commodified. The phrase, time is money, shifted from a philosophical metaphor to a literal, foundational economic reality.
Because if you own a textile mill or a factory, an hour of a worker's time equates to a highly specific, quantifiable amount of product, which directly equates to profit. Any deviation from the clock is a loss of capital.
Yes, to coordinate thousands of laborers to maximize that capital, cities had to impose strict, synchronized time. We see the historical rise of the municipal clock tower placed squarely in the center of town, visually dominating the landscape.
Everyone checking their pocket watches.
We see factory bells violently dictating the exact moment a worker eats, rests, and works. We see the implementation of rigid railway and transit schedules. Time ceased to be a natural phenomenon emerging from the environment. It became an abstract, unforgiving grid violently placed over human life.
The psychological shift is staggering. It feels like we went from a paradigm where time was a vast natural landscape we could leisurely walk through at our own pace, to a paradigm where time is a high-speed industrial conveyor belt, and we are desperately running just to keep from falling off the back.
That's a very accurate description. The modern city cannot function without extreme temporal synchronization. Traffic signal cycles, subway arrivals, shift changes, digital meeting invites everything as tightly mechanically regimented.
It has to be, or the whole system collapses.
And this strict regimentation manifests in observable empirical metrics. Researchers have actually quantified how this alters the literal pace of life across different environments.
Okay, wait. How do you practically measure the pace of life in a city versus a rural town? Like, what are they actually measuring?
Sociologists and psychologists conduct field studies using objective physical indicators. They measure the average pedestrian walking speed over a standard distance of 60 feet in various city centers.
Just timing people on the sidewalk?
Yep. They measure the speed of routine commercial transactions, for instance, timing exactly how long it takes a postal clerk to complete a standard stamp purchase. They even measure the accuracy of public clocks in bank windows and squares.
And the data confirms our assumptions. The larger the city, the faster the physical reality.
The correlation is undeniably direct and positive. As a city's population size and economic density increase, the physical tempo of human life accelerates. Pedestrians walk measurably faster. Retail transactions shorten. People even speak at a higher syllable per minute rate.
People literally talk faster.
Yes. The objective physical acceleration of the environment is an empirical reality.
We can prove the environment is moving faster. But how does that objective physical speed alter our internal perception of time? Does moving faster physically force our brains to believe time is vanishing?
It does, and the mechanism by which it happens is revealed through psycholinguistics.
Psycholinguistics, the study of language and mind.
The paper dives into how your physical environment actually alters the fundamental metaphors your brain uses to structure the flow of time. It changes the very language you use to conceptualize reality.
Wait, the words we use to describe time change depending on our population density.
Yes. Studies in cognitive linguistics show that residents of fast-paced, high-density cities overwhelmingly adopt what is categorized as a moving time perspective.
Moving time, what does that sound like?
In this linguistic framework, time is conceptualized as a fast-flowing river or a conveyor belt, rushing past a completely stationary observer. You hear it constantly in urban corporate environments. The holidays are rushing toward us, or the deadline's approaching quickly, or Thursday went by in a flash.
Oh, wow. In those phrases, the human observer is standing completely still, and time is an aggressive entity moving at them.
Exactly.
Think about how modern technology enforces this, too. Our calendar apps and smartphone notifications literally pop up and demand our attention. The notification slides onto the screen, the event is coming at you.
That is a brilliant modern context for it. It produces a deeply ingrained subjective impression that temporal events are uncontrollably rushing past you. You are stripped of agency. You can only brace for impact as the deadlines and events hit you.
And how does this contrast with rural populations? What language do they use?
Rural populations living with less synchronized clock discipline and a slower pace of life exhibit a significant linguistic preference for a moving ego perspective.
Moving ego.
Yes. In this metaphor, time is viewed as a stationary landscape, and the individual observer is actively moving forward through it. The phrasing shifts subtly but profoundly. We are approaching the holidays, or we are coming up on the deadline, or we are nearing the end of the week.
We are approaching. The human is the active agent moving through the space, and time is the stationary landscape.
Right.
That linguistic shift grants the speaker all the agency. If time is a landscape, I can choose to sprint, walk, or stop and rest. If time is a conveyor belt, as in the urban model, my only choice is to try to keep my balance.
Exactly. The commodified clock discipline and the physical acceleration of the city actively force us into a moving time mentality, linguistically stripping us of our temporal agency and making us feel helpless against the clock.
It permeates the deepest levels of our cognitive framing. The environment dictates the language, and the language reinforces the perception of pressure. That is just fascinating.
It really shows how interconnected everything is.
Which bleeds so seamlessly into the final major area of exploration in the paper, multidisciplinary echoes covering culture, gender, and finance. Because a temporal distortion this massive doesn't just stay isolated in an EEG scan or a linguistic survey, right? It echoes through every form of human expression and exacerbates real structural inequalities.
It touches everything.
Let's examine how this subjective experience of time shows up in art, starting with literature. The paper heavily references Thomas Mann's 1924 novel, The Magic Mountain.
The Magic Mountain is a masterpiece of phenomenological exploration regarding human time perception. Have you read it?
I haven't, actually. What's the premise?
Well, the narrative follows a young, ambitious engineer named Hans Castorp. He leaves his highly structured, fast-paced industrial life in Hamburg to visit his cousin in a remote tuberculosis sanatorium high in the Swiss Alps.
Okay.
He initially plans to stay for a brief 3 weeks. He ends up staying for 7 years.
Whoa! 7 years.
Yeah. And it's astonishing that a novelist writing a century ago perfectly encapsulated the episodic memory encoding model we broke down earlier. Mann didn't know about CA1 time cells, but he understood exactly how they functioned.
The literary intuition is remarkable. How does Mann describe the passage of time in the book?
Mann explicitly explores the linkage between spatial novelty and temporal duration. When Hans first arrives at the sanatorium, the alpine environment is entirely novel. The air, the bizarre routines of the patients, the medical procedures, the sprawling landscape, it is all new.
So it's like the first week of that vacation we talked about.
Exactly. And because of this novelty, his first few days and weeks feel incredibly long and rich. His brain is encoding dense episodic memories.
His hippocampus is frantically writing the massive video file of the fireworks show.
But eventually the novelty fades. The strict, unvarying routine of the sanatorium takes complete control. Every single day becomes identical. A heavy breakfast, a mandated rest cure on the balcony, a short walk, a heavy dinner, another rest cure.
Groundhog Day.
Basically, once absolute structural repetition sets in, subjective time completely collapses. Mann writes brilliantly about how weeks begin to flash by like days and years vanish like months. He describes how true, unvarying monotony shrinks time to a single, indistinguishable point.
It is the perfect literary representation of how a lack of distinct temporal markers causes retrospective time to effectively vanish.
It really is.
So literature has documented this psychological reality for a century. What about music? If literature reflects our narrative perception of time, music must surely reflect our internal biological rhythm.
Oh, without a doubt. Acoustic structures are deeply reflective of the environments that produce them. Consider the baseline acoustic environment of a dense, modern city.
It's loud.
It's characterized by high-frequency noises, rapid, jarring industrial percussion from construction and machinery, a persistent, low-frequency ambient hum from engines and electrical grids, and complex, intersecting polyrhythms of traffic and dense human activity.
It is inherently chaotic, high-tempo, and relentless.
And the musical genres born directly out of those urban environments perfectly mimic that mechanical infrastructure. Think of techno, industrial drum and bass, or high BPM electronic music.
Right.
These genres frequently utilize rigid grid quantizing.
Quantizing being the digital process where every single drum hit or note is perfectly mathematically locked to a mechanical grid, removing the natural microfluctuations of a human performance.
Yes, the music is mechanically perfect and unforgiving, and the tempos are high, often 120, 140, or even 160 beats per minute.
Which is significantly faster than a normal human resting heartbeat.
That is the crucial physiological point. Listening to this highly quantized, high-tempo music physically stimulates the sympathetic nervous system, the branch of your autonomic nervous system responsible for the fight-or-flight response.
Wow.
It elevates your heart rate, increases physiological arousal, and literally accelerates your internal temporal tracking. The music acts as a mechanism to align the human body with the relentless pace of the industrial machine.
And when we look at the music that emerges from rural or natural acoustic environments,
The contrast is stark. Natural acoustic environments have low ambient sound pressure, natural echoes, and slow organic rhythmicity. The wind doesn't blow on a quantized 44 grid.
good point.
Corresponding musical forms, pastoral classical compositions, ambient acoustic music, or traditional folk traditions rely on slow tempos, fluid and elastic time signatures, and unquantized, deeply human performances.
The musicians organically speed up and slow down, breathing with the music rather than adhering to a grid.
And physiologically, engaging with this music promotes parasympathetic dominance, the rest and digest system. It lowers the heart rate, reduces cortisol, and actually slows down the listener's perceived duration of time, allowing for that expansive, soft fascination state.
The cultural echoes are fascinating, but we really need to address the sociological impacts detailed in the paper, because this temporal stress is not distributed equally. There are biological and gender discrepancies that are incredibly alarming, bringing us back to the biological impact of light pollution.
Environmental stressors always intersect with biology in complex ways. The paper cites compelling transcriptomic and genomic research investigating how urban stressors, specifically ALAN, affect different demographic populations.
Right, the artificial light at night.
The findings revealed clear, sex-specific variations in gene expression related to circadian clock disruption.
Wait, the research indicates that men and women react differently to light pollution at a fundamental genetic level.
The transcriptomic data suggests that under conditions of chronic artificial light exposure, urban females exhibited distinct and altered gene regulation changes in their photoreceptor and circadian pathways compared to males in the same environment.
That's incredible.
It suggests a potential difference in evolutionary adaptation thresholds to light pollution based on biological sex. The severe circadian disruption we discussed, the delayed phase timing and melatonin suppression, might impact female chronobiology more acutely, leading to distinct physiological and metabolic consequences that are currently under-researched.
That carries massive public health implications that are entirely absent from the conversation when, urban planners decide to install brighter LED streetlights in a neighborhood.
It's a huge blind spot.
And this biological vulnerability is compounded by intense sociological pressures. The paper discusses the concept of the double burden.
Sociologists often refer to it as the second shift. In many global cultures, women living in urban spaces face the compounding demands of professional, commodified employment driven by clock time, overlapped with traditional, deeply entrenched expectations of domestic caretaking.
You work an exhausting 9-to-5 shift ruled by the corporate clock, navigating the high cognitive load of the city, and then you return home to the unpaid, unyielding clock of childcare, meal preparation, and domestic management.
And high-density urban environments maximize the friction of those spheres. Commutes are longer and more stressful, transportation logjams are frequent, and the logistical coordination of schedules is immensely complex.
Nonstop.
This compounding effect leads to a sociological phenomenon known as time poverty.
Time poverty. That perfectly describes the feeling.
It is the acute, subjective, and crushing feeling of having fundamentally insufficient time to complete necessary tasks for basic survival and well-being. The data clearly shows that this severe time poverty disproportionately plagues women in urban centers.
They are biologically impacted by the environmental light at a genetic level and sociologically trapped by an unforgiving schedule. It's a cascading failure of urban design.
Absolutely.
And speaking of schedules, we have to look at the ultimate apex predator of urban speed: finance. If time truly is money, then the financial markets are the ultimate timekeepers.
Cities fundamentally exist to concentrate labor, infrastructure, and capital to maximize economic throughput. In modern financial markets, Temporal acceleration has reached a scale that biological humans cannot even perceive.
We're talking beyond milliseconds.
We've evolved far beyond the open outcry trading floors, where human beings physically yelled across a room to execute a trade. Today, global capital is dictated by algorithmic high-frequency trading, or HFT.
Supercomputers executing thousands of stock trades based on incredibly complex mathematical algorithms.
They capture fractional economic value in milliseconds or even microseconds. Financial markets fundamentally model the time value of money via present value calculations. Capital today is worth more than capital tomorrow. In these high-density economic centers, the demand for immediate microsecond capital returns accelerates the operational timelines of entire global corporations.
A publicly traded company is no longer planning for the sustainability of the next decade. The executive board is panicking about the next quarter or the next week because the algorithm demands immediate growth.
And that macro-level economic panic trickles down the hierarchy. If the financial algorithm demands instant returns, the corporation demands faster production.
The middle manager demands faster output from the team.
Exactly, which ultimately penalizes any delay, any rest, or any friction in the average urban worker's daily life. Speed is aggressively monetized at the very top of the financial structure, and the resulting temporal anxiety and stress are distributed to the bottom.
It is a cascading waterfall of temporal anxiety, which makes the final contrast presented in this section so vital. The paper contrasts this secular, hyper-financialized timeline with the ancient concept of sacred time.
It is perhaps the most important contrast to consider for our well-being. Across indigenous cultures, agrarian societies, and traditional religious practices universally, time is constructed fundamentally differently. Sacred time is cyclical, not strictly linear.
Cyclical time.
Yes, it is demarcated by seasonal festivals, solar or lunar calendars, designated Sabbaths, and periods of ritual fasting or rest.
It consists of deeply ingrained cultural structures that explicitly force the society to stop.
Sacred time periodically resets the social and psychological clock. It intentionally interrupts the mundane, linear daily routine and mandates reflection. It provides built-in, culturally enforced pauses that slow down human temporal perception and allow for community cohesion and episodic memory encoding.
But rapid urbanization and secularization strip those pauses away entirely.
Urban secularization replaces those natural, cyclical markers with the demand for continuous, unbroken commercial availability. The 247 economy.
The store that never closes.
Modern urban spaces transform time from a natural phenomenon to be observed and lived within into a scarce, highly monetized resource to be exploited continuously. The built-in reflective breaks that historically protected human psychology are simply gone.
We paved over the Sabbath to build a 24-hour drive-through. It's a stark reality, but it encapsulates exactly what has happened to our environment.
It really does.
We have covered an immense amount of ground today, and it is time to synthesize these findings. Let's summarize the true verdict of Victor H. Sertuchin's hypothesis. The initial intuitive idea was that cities are boring, repetitive structures that make us space out, while nature provides stimulating novelty.
And the multidisciplinary data has definitively disproved that mechanism while validating the core subjective phenomenon. Time does feel as though it is accelerating in the city, but it is absolutely not because we are understimulated. It is because our neurobiology is profoundly overloaded by the demands of hard fascination and directed attention fatigue.
Our prefrontal cortices are exhausted from playing defense against the sensory fire hose.
Yes, and because our brains are metabolically exhausted, depleted of ATP from forced global visual processing, our hippocampi are starved of the distinct, novel, episodic memories required to lay down a robust retrospective temporal record.
We compress the month because we lack the energy to record the details.
Furthermore, our circadian rhythms are being actively hijacked by artificial blue light, suppressing melatonin, desynchronizing the suprachiasmatic nucleus, and pumping our bodies full of stress hormones that create biological panic.
And layered on top of all that internal biology, our external culture has commodified the clock, accelerated the physical pace of life to satisfy microsecond financial algorithms, linguistically stripped us of our temporal agency, and dismantled the sacred pauses that used to reset our minds.
The takeaway is that if we want to actually slow down our perception of time, the solution isn't just taking a brief vacation to recover. The paper points toward the necessity of systemic environmental change.
How do we even begin to do that?
Urban planners need to integrate biophilic design, bringing natural fractals back into the concrete grid to allow for soft fascination. We must advocate for dark sky initiatives and biologically appropriate municipal lighting to let our pineal glands function naturally. We need to create unregimented spaces that allow human neurobiology to recover its natural temporal cadence.
It is not a matter of finding a way to cram more tasks into the time we have. It is about fundamentally altering the environment so our brains have the capacity to actually record and experience the time we are given.
That synthesizes the science perfectly.
Which brings us to the close of our deep dive. But before we wrap up, you shared a final thought experiment with me when we were reviewing the oculometric data. A concept that takes everything we just discussed about memory and environment and pushes it to the absolute frontier of speculative science based purely on the data.
Yes, I want to leave the listener with this thought to mull over. If our entire subjective perception of how long our life lasts is dictated by our physical environment, and
Yeah.
specifically by how our brain manages cognitive load and encodes distinct episodic memories in the hippocampus, could we theoretically engineer an environment that hacks this biological system completely? Perhaps through highly immersive generative virtual reality or targeted neurostimulation? Could we artificially induce a continuous state of perfect soft fascination, resting the prefrontal cortex while simultaneously feeding the hippocampus highly salient, non-fatiguing, endlessly novel stimuli?
A perfect artificial memory generator.
Could we engineer an artificial environment that is so optimized for episodic memory encoding that a single Tuesday spent inside it feels like it lasted 1,000 years? If poorly designed, chaotic cities have the passive power to artificially compress our lifespan and make the years vanish, do we currently hold the technological potential to deliberately stretch our perception of time into a state of near immortality?
That is a staggering, mind-bending thought to end on. Could we technologically stretch a single day into a subjective lifetime? Thank you so much for joining us for today in the hypothesis. If this deep dive changed how you look at the clock on your wall or how you experience the walk down a busy street, please subscribe to our feed. And more importantly, share this with a friend, specifically that one friend who is always rushing, always stressed, and always complaining about never having enough time. Let them know it might just be the streetlights. Until next time, find a quiet place, look at a tree, and let your brain space out.